Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Atirah binti Shuaimi.
Hi, Assalamualaikum. My name is Nur Emina Liana binti Muhammad Taha.
My name is Nur Shasha Shafinas binti Khairul Anwar.
The objective of this experiment is to investigate the relationship between total forces acted on an object with acceleration of the object and to study the Newton's second law of motion. This is the apparatus for PET simulation. The procedure for non-friction surface is: number 1, you need to proceed to force graph tab, and you need to set the parameter setting as object, small crate, friction, ice, no friction, and you have to add acceleration graph by click on acceleration button. For the first data, set the force applied to 500 Newton, and then you press play button to begin. After that, record the acceleration and tabulate the results in table 1. Then click reset all for second reading. The last step is repeat above steps at least 3 times for each data and repeat step 2 until 7 for another 9 data. The procedure for friction surface is: first, proceed to force graph tab, and second, the parameter setting as object, small crate, friction, wood, and you have to add acceleration graph by click on acceleration button. For the first data, set force applied to 500 Newton, and then you need to press play button to begin. The fifth step is you need to record the acceleration and tabulate the results in table 2.2. And click reset all for second reading. And lastly, you need to repeat above steps at least 3 times for each data and repeat step 2 until 7 for another 9 data.
Okay, now I will show you the data for non-friction surface. Okay, firstly, here we have applied force, friction force, total force, and acceleration. The force, the unit for force is N, Newton or N, while the unit for acceleration is meter per second squared. Okay, firstly here we have force 500 Newton, and because the force friction is 0, so the total force will be 500 Newton. The acceleration here will be 5.00 meter per second squared. Here I got it another 3 times and the results got same, which is 5.00 meter per second squared. This is applied for all other data too. Okay, second we have 600 Newton and the acceleration is 6.00 meter per second squared. 700 Newton got 7.00 meter per second squared. 800 Newton we got 8.00 meter per second squared. 900 Newton we got 9.00 meter per second squared. 1000 Newton we got 10.00 meter per second squared. 1100 Newton we got 11.00 meter per second squared. 1200 Newton we got 12.00 meter per second squared. 1300 Newton we got 13.00 meter per second squared. And the last one is 1400 Newton we got 14.00 meter per second squared. For the A2, A3, and A4, as I repeat the procedure and I got the same data for all of them, which is the same as A1. Okay, next is the data for friction surface. For the first data, applied force is 500. Since it uses wood surface, so it have friction, so the friction force is negative 294. So the total force is 206. The acceleration is 2.06 meter per second squared. For applied force 600 minus 294 frictional force, we will get 306. The total force is 306. So the acceleration will be 3.06 meter per second squared. Next is 700 minus 294 equal to 406 total force. We will get 4.06 meter per second squared. 800 Newton minus 294 Newton equal to 506 Newton. we will get 5.06 meter per second squared for acceleration. 900 Newton minus 294 Newton, we will get 606 Newton, which is the acceleration will be 6.06 meter per second squared. 1000 Newton minus 294 will get 706, the acceleration will be 7.06 meter per second squared. 1100 minus 294 equal to 806, the acceleration will be 8.06 meter per second squared. 1200 minus 294 equal to 906 Newton. The acceleration will be 9.06 meter per second squared. 1300 minus 294 equal to 1006 Newton, and the acceleration will be 10.06 meter per second squared. The last one is 1400 minus 294 equal to 1106 Newton, and the acceleration will get 11.06. Same for the non-friction surface. The procedure was repeated for a few times. Here I repeated for another 3 times, and the data for A2, A3, and A4 are same with A1. Okay, next we'll move to analysis. Okay, first, from the data, plot graph for total force as a function of acceleration for non-friction surface. Here we highlight for non-friction surface. Okay, here is the graph total force as a function of acceleration for non-friction surface. Here we plot the graph. The same with the data we got, and here we got straight line. Next we'll find the gradient. Here 1600 minus 200. Bottom one I took 16.00 minus 2.00, so the m I will got 100. So here the acceleration axis, the x-axis is acceleration, and y-axis is the force, which is the unit is n, while the acceleration is meter per second squared. Okay, next, the second graph is total force as a function of acceleration for friction surface. Here I plotted the graph and I got straight line. Next, I will find the gradient, which I got. The gradient is 100 Newton meter per second squared. Next, the number 2 from both graphs. State the relationship between the total force with the acceleration of the object. So here, the relationship is when the force is increasing, the acceleration is increasing. Okay, the third one, does the graph obeys Newton's second law of motion? Explain. Okay, here I conclude it as yes, the graph obeys Newton's second law of motion, because based on the relationship just now, the force is increasing, so the acceleration is increasing, because here the acceleration is directly related to force. So when the force goes up, the acceleration goes up. Determine the gradients or slopes of the graph. What do the gradients represent? Explain. Okay, here the gradient represent mass. This is because the gradients of graph y and graph x is equal to f per a, which is f per a equal to m, or mass. Okay, next, the last one is using Newton's second law of motion, prove that the coefficient of kinetic, friction here, between the small crate and the wood surface is 0.3. Okay, firstly, we use coefficient of kinetic friction equal to F per W, which is F is frictional force while W is weight. Okay, next we put it 0.3 under the coefficient of kinetic friction given, which is 0.3, equal to 294, which is frictional force, and then 981 is the weight. Next, I got 0.29. We round it off, so it becomes 0.3, so it's same. So it proved that the coefficient of kinetic friction is 0.3.
To investigate two things, which is to investigate the relationship between the acceleration and also total force act of an object, and also to study the Newton's second law of motion. In this experiment, we use a small crate and do the experiment on the two different surfaces, which is on the friction area and also non-friction area. After we do all the experiment, we record all the data. All the data were plotted in a graph, and the graph showed that acceleration proportionally directly to the total force number. But in this part, both of the graph show the different number of the total force and also the acceleration. It is due to a friction. Friction is a force that happens between two objects sliding to each other. friction work in the different direction to the object direction that make the object move harder and slowly. We can relate with this experiment, which is when the small crate move on the friction area, the small crate move more slowly, and we can relate to the Newton's second law of motion, which is the acceleration will directly to the total force of motion. We can conclude two things. Firstly, when the total force is increased, the acceleration is increased. Secondly, the Newton's second law of motion shown that the acceleration move proportionally with the total force number, which is when the total force is goes up, the acceleration is goes up.